Hello, everybody. Hey, this is our next lecture on acceleration, and we're going to talk about the acceleration due to gravity. So let's think a little bit about what gravity is. Gravity is one of those fundamental forces that causes every bit of mass to attract. So if we have the Earth here, the reason that we stay on the surface because of gravity, because the Earth and ourselves are being attracted to each other. So if we are just standing on the surface of the Earth, there is going to be an attraction due to the Earth. And that is the force of gravity. And the equation for the force of gravity is mass times gravity. So the more mass there is, the heavier an object is. This would also be known as weight. Okay, more mass, it's going to be heavier. But today, we're going to talk about this value right there, which is G. And G is the acceleration due to gravity. Okay, so now that G is equal to 9.8 meters per second squared. Now remember, that's an acceleration, so it's the change in velocity over the change in time, meters per second, meters per second squared. Now, you guys, this is a little more precise, but we are going to use 10 meters per second squared because that is a little bit easier number to work with. All right, it makes all of our calculations a little simpler. Okay, so we're going to talk about the equations that I gave you before. Okay, now that is the average velocity, you may remember, is x final minus x initial divided by time. That was also equal to velocity final plus velocity initial divided by 2. This is if we have a constant acceleration, right? So very often we'll call that kinematic equation number 1. And kinematic equation number 2 is V final is equal to V initial plus AT. Now, remember, this equation comes directly from the change in velocity divided by the change in time. These two are the same thing, they're just rearranged. Okay, now we haven't done this in the worksheets really yet, but I did talk about it in our last lecture, and that would be the change in displacement is equal to the initial velocity times time plus 1/2 the acceleration times time squared. And then there is a fourth equation, which is V final squared is equal to V initial squared plus 2A delta X. All right, so if we have all these four, and when you guys are doing a quiz or something like that, you guys can have all these equations. Now, just like these, you can change them around algebraically. So why would we have these four? It kind of just makes it a little bit easier to kind of see all of these things. But when you're doing these problems, okay, in this first equation, there is no variable for A. Even though this can be accelerating, there's no A in there. And for the second equation, there is no X. There's no displacement. And in this third equation, there is no final velocity. And in this last equation, there's no variable for time. There's no variable for time. And so if we look at how many different variables we have, we've got 1, 2, 3, 4, 5, 6, 7. So there are a total of 7 variables that we could have in these type of problems. Now, the good news is in order to calculate any value, all you need to know is 3. All you need to know is 3. And then you can choose whatever equation that you need and you can solve for it, even if you have to manipulate the variables a little bit due to algebra. So where does gravity come into place here is that whenever we have free fall, okay, whenever we have free fall, okay, we're going to have free fall, okay? That means if we drop something or throw it or kick it or anything like this means that it's going to be free falling in the air. And if we have it free falling, then it's going to have an acceleration of g. So we can have g, g, and g. Okay? So sometimes if we just say drop a ball, okay, and we don't give you any other numbers, well, the drop means is that the initial velocity was 0. And because we dropped it, our acceleration is going to be 10 meters per second squared, 10 meters per second squared. So let's talk about a couple of examples here. And one would be, hey, how fast is an object going to be going after 1 second if we drop it? Okay, so our equation V final is equal to V initial plus GT. Okay, now this is kind of like a speedometer. This is kind of like a speedometer on a ball. So we might have something like this where we have a speedometer. I'm sorry, yeah, speedometer. So it's how fast is it going? All right, now I said drop, so that means our initial velocity is 0. And it also means that our acceleration is due to gravity, so that's 10. And so if we have 1 second, okay, then after 1 second, our velocity is going to be 10 meters per second. Well, what if we have what if we have 2 seconds? All right, then it's going to be 20. And those units are going to be meters per second. Okay, what would it be if we went for 5 seconds? Well, if we went for 5 seconds, we can just follow this pattern, and that would be 50 meters per second. So remember, with this, it's going faster and faster and faster. Okay, so if we just want the final velocity, it's just going to be 10 times however much time there is, and that tells you how fast you're going. All right, now what is going to be a little bit different, and we haven't had a lot of these problems yet, okay, is how far does it go, okay? And from equation number 3 is telling us what our displacement is. Okay, so we're going to start, again, if we drop a ball, how far does it go after 1 second? Okay, so our equation is delta x, which is going to be our displacement, is equal to our initial velocity times time, plus 1/2 at squared, except our acceleration, because we dropped it, is going to be g. All right, and we also said that our initial velocity was 0 because we dropped it. So now we can just say delta x is equal to 1/2 of 10 times time squared. So essentially what we have is x, our distance, is equal to 5t squared. So after 1 second, we're going to have 5 times 1 squared, and that would give us a distance of 5. But notice if we have 2 seconds, that gets squared, and 5 times 4 would be 20. And if we have 3 seconds, that gets squared. That's going to be 5 times 9, and that's 45. So notice, because it's accelerating each second longer, it goes farther and farther and farther. Okay, not in a linear sense, but notice from 0, it would go 5, but after 2 seconds, it would be 4 times greater. And after 3 seconds, it would be 9 times greater, okay, than this 1 second, okay? So that is another equation on how to calculate how far it drops. So that is from equation number 3. And then we also have how fast it's going, and that is from equation number 2. So this one's a little bit easier. We're just going to multiply 10, or the acceleration due to gravity, times whatever our time is. And in the how far, that is going to end up being, again, this is if we drop it, that's going to be 5, or 1/2 of our g, times t squared. Okay, so that's all we're going to go over for now. So next week, you're going to see some problems that are going to involve g in some worksheets. So until then, we are good to go.